Hello everyone, welcome to my channel. My name is Kim Sir. I am an undergrad student at Paragon International University, majoring in computer science. I am currently attending a course called Computer Architecture here at Paragon. And for our final project, me and my two other friends have decided to choose a topic about low-level programming application. So instead of focusing on something like assembly or something, our team decided to we wanted to build a RISC-V simulator in C, but it's not like it's basically like kind of like a CPU, but not the whole CPU. We're just implementing 10 instructions, and instead of the 5-stage pipelines and all those fancy and complex stuff, our project we will only like single clock cycle. And if you guys don't know what RISC-V is, it's basically like instruction set is open source, basically meaning that anyone can use it. As to if anyone wants to design a computer chip on their own, they can use the RISC instruction set as like a reference, say, because for computer architecture, like the x86 like Intel or AMD, it's not free. You have to buy the license, but for this one it's free. So if you guys are interested in that, you can check it out on the internet on your own. For starter, I'm not actually building everything from scratch. Luckily, I searched around YouTube while doing my research, and I found this series from low byte production series called like RISC-V CPU in TypeScript. So all credit goes to him, and I will be using his video as a reference. But technically I'm not copying everything from him, because he is like actually making a whole RISC-V CPU in TypeScript. It has all like 5-stage pipeline and stuff like that. For mine, I'm only using building 10 instructions. It's just a single cycle, but I'm writing it in C, so technically it's different in a way. Before we get into the coding, there is this. So for C, this is like the system architecture, the architectural design that he used, and I will also be using it as well, because I think it's a good design, and maybe it's just how it is. But let me explain it to you. So imagine that this is the CPU, and if the CPU wants to communicate with the hardware, these are the hardware. We have ROM, RAM. This is like universal asynchronous something. I forgot the full name. And this is the LED. So if the CPU wants to communicate with any of this hardware, it needs something called a system interface, which is like a bridge to like let the CPU and the these are called MMIO devices, memory map input output devices. They allow the CPU and the MMIO devices to communicate, and the CPU only know which hardware to access through the system interface, where we input the address here, a 32-bit address, and based on the address we will know which hardware we are trying to access. And data can also flow back and forth between the CPU and the system interface and these. And of course the CPU can read from here, read to these devices, or write to them as well. Technically you can only read and write to this. You can read both of this, but you cannot write to ROM. Good, I think. So enough of the introduction. Let's go into the coding part. So first, here you see that the system interface I just described, it can read and write, right?
Export.
So this is gonna be a bit difficult because in C there is no, it's not a OOP paradigm language. You know, there's no class, there's no interface. So I have to. I don't know what I should do. Let's see. There's no class, but we have struct. So I guess we can like create something for let's see. That's okay. So the class is kind of basically the function. It interface. We don't have interface, but interface is basically like a contract where we don't implement functions. We don't actually implement the functions or methods. So I think we can, if we want to create something like this and make this class or function implement it, I think the only way would be to create a header file, right? Let's see. So if you don't have interface, we have struct. So we can say struct MIO device. I don't know TypeScript. I know that number is probably like any, it's a data type, right? But like, what's the size of it? What, let's see. What is so it's a primitive. So basically, it's all numeric value. Oh, I forgot to mention. The CPU that we are building is a 32 bits architecture. So if it's all value, n is 32 bit. So I guess we can use n. We can say okay. So the class, it needs to have to interface is basically like contract. You don't specify how these two functions will be implemented, but just know that any device that implement this needs to have these two functions. So we can write, it takes in an address which is in 32 bit. Wait. Okay, it's 32 bit, but I believe it is signed. It is signed, meaning that because okay, here I think it's better we use the unsigned. I think it's so the thing is, address cannot be negative, right? But if we use integer in data type, it might cause some error in the future. So this unsigned is, let's see, in 32, was it? Is it not this? Wait, let me include the library. Nice. We take in an address and oh wait, alright. So it's struct we cannot implement function. Oh yeah, it's pretty much it's very similar to interface. We cannot implement function inside a struct. So if we want to do this, we have to use a pointer, because if we do not make this thing a pointer, it will think that we are trying to create a function prototype, which is not allowed inside a struct, because a struct cannot have raw function. It can only hold struct can only hold pointers basically. Let's create the right function address value. Okay, all good, I think. And then he has a class, so but you can see that he is implementing the function, so it's definitely not a header file. Just call it system interface.c. Since they implement the MMIO device, we have to include it. What is it? Okay, MMIO device. Alright, but I still remember it. That's it's a good practice to always put this at the top of your header file, because in the future soon you will see that when we include a lot of header files, we only want to include them once. If we include it more, it might cause us some error. So by using the pragma once, you will include this header file will be included only once. So he has a read function. It takes in address, so it should, and say it takes in 32-bit address, it should also return a 32-bit address, right? So read address, makes sense, right? But so our write function, it taken address and t value. For now, I don't know. It's not returning anything, so let's just put this void for now. Actually, this function should be static. We don't want to accidentally change it in the future. Okay. This is good, I think. So up next we have to create ROM. Oh, okay. Okay, it's pretty straight, I think. Yeah. Now we are okay. First let me create a folder called system interface. I will put this in just for simplicity. Let's see. Here's a ROM. Let's see. Okay, so you see he is importing ROM device. So it means that ROM is a class. Well, to import it, if we want to import ROM, then we need to make it a header again. Say ROM device the header. Let's just put this pragma 1. Not that struct, call it ROM device. ROM is ROM is an MMO device, so we need to include that. Oh man, I have to include everything manually every single time. System. Why is this an autofill for me? Oh my god. System interface. Okay. That was quite frustrating. Let me just. I'm so tired. Should work. Okay. Since it implement this, it should have this function as well. And we want to shift like this. Okay, nice. Sorry. Okay, let's call this ROM. ROM. Oh, I forgot to put it in here. Actually, let's create another folder. Let's create a folder called header where I just put everything in here. Okay, then header, and this should be header. Oh my god. Header. Okay. Okay, so he oh, so we C also don't have a constructor as well, and since we don't have the constructor, what should we do? This is really difficult working with OOP in a non-OOP language. I guess I can let's see. I think I can. I guess we don't have a private variable, but we can say we can. I think by wait, let's how should I do this? Well, okay, we can create something called private ROM, I think, and it should probably it should probably be static as well. You don't, yeah, and ROM is part of ROM device, and initially it should be null. Yes, and no. To include something, I think include. Let's see if it's remember def. Is it like this? Was it this one? It's not that one. Wait, maybe this, maybe library, maybe the library. It's not that one either. Wait, it should be this one. I think it was definitely, yeah. What's this? Well, let me read the error. A value of void cannot be used to initialize an entity struct. Right, struct can only be a pointer. Right. Okay. let's see. So okay, so technically now this is the same. I can just call it, yeah, technically now this is the same because with pointer it kinda act the same way as a private keyboard. And the reason that we use pointer is because you see that when he created this constructor, he used this keyword, and that this keyword will point to like the ROM from the ROM device interface. It's set it to here, and so the way that we like to assign like that is to use pointer, right? Basically, I don't know what I'm saying, but basically I just know that ROM, the pointer act similar, basically are the same as this keyword. So shoot, we don't have a constructor either. This is a constructor for system interface. What do we do? We could say maybe we could create like a function prototype. Let's say struct say the constructor is for creating the an instance of the system interface. So we can say system interface a, yes. That's I should probably actually I want to keep writing struct every single time. So let's use do this def and my old device. Now if I were to, well, yes, it should be okay. Yeah, same for this too. I don't want to keep writing struct type def definition. Type def is basically like for giving nicknames to like a variable or something. So ROM device is okay. Okay, now I can just say ROM device. Oh no. I'm on my old device because we want to create the system interface first, right? So we can say system interface. Yeah, see, because I put it. Oh, it works. Yeah, I put the function prototype. Function prototype here. So now when I just put the my old device and I just write this, and you see I have this here. Okay, I think that works. For now, let's say ROM. Okay. So to do this, we have to accept the variable. We have to put this in here. We have to put a parameter inside our prototype. And to do that, I have to include ROM first. So it's a system interface header and ROM, and then I can say ROM device ROM. Does this work? What's not good now? Declare at line 17. Alright. I keep forgetting this. Wait. Okay, that's not a problem. What is it? Oh! I didn't put it. Oh, yeah. My god. Okay, I can say ROM device. We'll accept ROM, and we can create a more device, and we can say device. See ROM. We call ROM. So what is ROM equal ROM? Let's see. Alright, you can just equal ROM like this. I think this, yeah, this works. It should work. It should really, it really should work. What's this? A volatile. A volatile of ROM struct. Oh, wait. It is because it is struct, right? So if we were to it's a struct. ROM is a struct. That's why we have to put it. Okay, nice. This thing should return device for now. Okay, so this is we got the constructor down.
System, the RVO.
Next. Actually, this is not all. Right now, the device is we create a device which is you say MMIO device class or struct, but the thing is it refers to this and it doesn't know which it doesn't have any implementation of the function yet, right? So if we want let me just show you. If I type device and I do like this, I mean here. You see that it has read and write. That is because we put it here, right? But right now it has no implementation. So how do we make it? How do we make? We want to the system interface will have read and write. So we can say read, and we say this system read. So what? Okay. So what does this do? When I say device.read, it will set it refers to this pointer, right? So when I say device.read equal system read, I'm basically assigning this pointer to point to this function. So now if I were to use device.read, it will execute whatever code is inside this function. But now we don't have any code yet. But let's do the same for the write first. Again, I'm just assigning the pointer to the function, which the function actually have implementation. Let me return a device.
Actually build the ROM first. So as for cost or size.
What is he doing? Okay, so he is defining the size of the ROM and then creating array.
That's so many different things.
Is he talking about? Let's see. Oh, so this is basically for like it's a wrapping function. So basically, if someone try to read or write, say if someone try to read or write at an address, read or write at an address that exceed the ROM size, it will wrap back to the beginning. I think that's a logic here, because he used the bitwise what's it called, function, the bitwise operation between address and ROM size -1, basically the total size. So this will wrap, right? If it exceeds the ROM size, if it exceeds the ROM size, for example, imagine array here, it ends like here, and someone try to put it here, so then it will loop back to the beginning. I think that's the logic. Okay, and this is an array for loading the function, if I'm correct. Okay, I think I can do that. Let's just, instead of x constant, I'm just gonna define it. I'm just gonna define ROM size, and then 24 times 24, but to tell that it's an unsigned, I have to do like this. The use just tell that, okay, this is to treat it as an unsigned. I go to remove this. Yeah, this is like the signed integer. You just put u. Now suddenly it's yeah. Oh wait, this is RAM. Or is it? Or is it?
I think every instance of the word RAM here. Still was going to take the. Yeah, let's just replace it with RAM.
Wait. Oh wait, my bad. We're not supposed to do this in here. Again, whenever like you want to implement a function, like you actually implement the functions or methods, you have to make it a C file, C extension file. So I have to create a file called, okay, that's rom device.c, include system, like this, ROM, let's see, MMIO, right? System, okay, and then system interface. I think I don't need this since okay, but just add it. Let's make sure that I prep my, okay. So he implement function in here. So first let's define the ROM size. He put it as that's 1 megabyte, I think. Is one okay, why so little? I don't know. Okay. ROM, private ROM. Okay, so he has functions here. Yeah, I guess I think I can just copy right from here the function. The system just change the name. So we could say change this to ROM ROM. Why does ROM even have a write function? Anyway, let's see. Private ROM. Call a new array. So for unit 32R, I think is unsigned in. Okay, we can just declare an array of that just use the here just declare the array as its type. Okay, let's do that first. That's oh my god, I have to declare the array, huh? Declaring the array. To create an array, I think I should put it here. He put it inside his class, so it should be a struct. So we can say I don't know, ROM buffer, I guess, and yeah, I think I need to do it. Oh, excuse the notification sound. Okay, sorry, I need to let me turn off the notification sound real quick. Okay, actually, I think it's better. We need to put the ROM sign here. I think it's better if we, it should not define it in the implementation. If I were to define this here, I think I can use ROM size divide by 4. And why we divide by 4? Because it's something called word size. Here, word size. So word size for 32-bit. So it's like one address is worth 4 bytes here. So that's why we are dividing by 4, so that we get the actual address. I think that makes sense, right? So let's see. Okay, now that we get that, we can private ROM equal array size. How can we do that? Because we already created the array, so we just need to return the address. The address, huh? Okay, then I can do that. So I think I guess private ROM thing. I have to do like this. Yeah, this should not be. Oh, I implemented the wrong freaking file. Okay. We need to create like static. We need to create a ROM first. Just like a ROM that acts as the array. So we can just say global ROM data null by default, and include the library. Okay, nice. So this will represent, like, I guess it's basically the ROM. So if you can access it, you can say return history. We can put like this, the buffer should ROM buffer. You should take in an address. Oh, it takes an index. Okay. Then to this is an array. Get the index. Guess we can create something like just call it index. We can say ROM read device. And we say take the address. You want to read the address, so he has this wrapping like what's it called, wrapping methods here. So that copy it. So was ROM size. We have ROM size because we include the library of ROM by 4, and that's 1. Okay. Index, this should work. I think this is alright. I think this is the same. It should be the same. Okay, it is the same. I'm sorry if this so far is like really confusing. Like I actually don't know much C myself. I only learned C++. So like it takes me a while to figure out the syntax for C, like the type, stuff like that. Anyway, it seems that he also has a load function. So if since like we're saying that this ROM device implement ROM device here, header here. So if this were to have any function, the ROM device must also have that as well. So we can say is it load function? Okay, call it load. It takes an array. Takes in an array. So 32-bit array, right? So we can say I guess data. Let's see. Why? Oh, right. I keep forgetting. You know what's wrong? I didn't make it as a pointer. Yeah, see now it's gone. So I think we don't need to really do that. Static. Now I will be making like the load function. Declare the data type. Load. Say ROM load. Guess we can. You want to load in global. Huh? No. We're not loading in the global. No, we're not loading in the global. No, this is different. We're loading in data, which is 32-bit integer, but loading an array of unsigned 32-bit integer. But if I just pass, I have to do this. And I keep using pointer, but if I don't put pointer, it will refer to a single variable. That's why I have to use the pointer to say that, oh, this is an array. And let's see. What should okay? Let me read the. What's this loop trying to do? Interesting. But first, wait, before we get it, I think we should make the data constant just for safety purposes. ROM. Okay, so it loops to. Oh, it's just inputting data. Okay, I see. So, what's this? What's that? Let me search. What is OXFFFFFFF? Is commonly returned to signal failure. Oh, that makes sense. Yeah, that makes sense because here you see if so I is like kind of like the size of the total ROM, right? So if I exceed the length, it means that you're trying to load something that onto an address that does not exist. So it will set this value to FFF, which means that probably to just show that okay, this is an error. But if it's if if the address is like within the size, we input it in. Okay, yeah, I get it. Let me take a break a bit. This is way harder than I thought. Okay. Oh my god. Okay, so ROM load. Data length. Wait, but C++ doesn't have like the length. Does C have the length for array? Oh no. Wait a minute. Oh no. So how will we know the length? If oh no. Why does it not have length? Let me think. Maybe we have to like I don't know. First it has to like load, right? For loop for ni no not n less than ROM size -4. I think I should probably do this. So if I is less than data length, but we don't have the data length. I think data length. No, it doesn't. But what if we pass it in? What if we, since this is like a simulation, I should be able. Since this is a simulation, I can just like declare the length on my own, right? I can declare the length. Yeah, it's just a, since this is a simulation, I can input the fixed length of the array, and it's, well, I know, but it's still acceptable, because the point of this project is just to show that this whole simulator will work. So wait, why are I checking? Okay. Data length then. If it's it, then we can say global ROM data. No. ROM buffer at I will be equal to data I. It makes sense, right? And if not, we will say global ROM buffer I equal 1, 2, 3, 4, 5, 6, 7, 8. I think it's something like this, right? Oh wait, this. I forgot to create the constructor for creating the ROM device. This is just a function, but we haven't actually created a ROM device yet. Oh wait, yeah, I just added this. So you int32 data length. Okay, nice here. Okay. ROM device create. Should take what then? I guess it should take in nothing to be honest. Actually, yeah, take in nothing. Just creating a ROM. Then the constructor, we need to implement this function. So how is it? ROM device create void global data none. We can say ROM device to okay, this keyword again. I think I made it a pointer, right? So I can say device dot device dot read equal ROM read device dot write equal ROM write device dot load equal ROM load. Yeah, this worked. Thing and device. So now that we have the ROM, but let me drink water a bit. Okay. Okay. So when we load the data, it loads into global ROM. It loads into global ROM. But if you want to, and after that, you just go into ROM. Then say global ROM data equal device. The global ROM equal the ROM that we just created.
Okay, so that's ROM one is going to be, I guess, a little bit easier, but pretty much the same.
Let's see. We're not loading into RAM, huh? Okay, that's done. Let's do that. Create a new file. RAM.c. Man, I'm tired. Just RAM. Is there a fast? There's probably a faster way to do this. There's no. Yeah. And there's no. Oh, there's no. Nope.
A load of random crap in the RAM in the beginning, because it would be.
Yeah, there's no need to load. We just load it up ourselves. Okay. I think I don't have. Oh, okay. I need to.
Really, that is what it's going to be like.
I should probably create a RAM header file. Notice that each of them is a C file, and also it's like the same name, just header file. So ram.h. I'm just gonna copy this and I guess. Oh wait, where is the creator folder? Just create a new file, ram.h. I think he increased the size and okay, ram read this. Does it need a buffer? Guess a RAM should have a buffer, right? Yeah, it needs something to store it, so it should. Yeah, it should probably have a buffer. Okay. Showing. Nice. Let's shift this. RAM. I forgot to put it to device. Okay. Why is it showing error? What's this? Include error detected. Did I misspelled? RAM device. Why is it showing the error here? I don't get it. What? What? Oh my god, bro! What is wrong with this thing? But RAM device create. No, taking anything. Why you? I already put it, so why is it showing this? Maybe what? Yeah, RAM device. RAM device is. What do you mean it's undefined? Yeah, I gotta change it. Okay, now it should work. And RAM device with a device start. Right. RAM right. And read and Okay, I think that's enough. What's this RAM buffer? Got to change it again, didn't I? Wait, I already changed it. ROM has no struct. Yeah, there we go. Okay. The same channels. Okay, so this time we're returning. We're still not returning anything. We're just setting the value. Okay, global RAM data. We can call it like that. What? My brain's not working. We access the array. Where? I guess we okay, we set the address to value. I think. Let's see. I think it's the same thing, but he also, yeah, I think it's the same thing. Except I forgot the wrap function. Okay, the wrap round function. RAM size. Do not have RAM size. I forgot to. Oh my god, bro. Okay, RAM size. 4 and guess -1. What's this? Okay. Why is it showing an error expected? What do you mean? Forgot one. There we go. Nice.
Like on the hardware.
Let's see. Okay. I think I should probably create a memory map. Yeah, probably should probably create this enum. So I guess I can call it memory map. Yeah, doesn't need to be. It doesn't need to include anything, so I can just say type that in num. Let's see. So program and ROM start for 1 2 3 4 5 6 7. Then program n equal have the last address. It's basically the last address. All 1 2 3 4 5 6 7. Oh, it's not like this. Wait, my bad. Then we have RAM start, I believe. Just since this one is probably 2, right? 1 2 3 4 5 6 7, total of 8. Then we have RAM n 1 2 3 4 5 6 7. You get it? Nice. That's it. Oh, I forgot to type that. Okay. Let's call it memory. Will this work? Okay, nice. Okay. This is so time consuming. System and okay. I have to include the memory. Okay. Where did I create this? But now we have RAM and ROM, and now he has RAM and ROM. Let's see. Oh, here, see what I told you earlier, the why we have to like divide the RAM and ROM size, like here, like why we divided by 4. You can see that each a word is basically like a 32-bit number, or 4 bytes, and it creates a one address. So total you have 8. Here you have 8 blocks, right? But you need to divide. If you divide 8 by 4, there's actually only 2 addresses. So that's the logic behind it. And I think here he is explaining. What is he explaining? What's this? I don't know. For now, let's just create the private RAM and put it into our constructor. So I included this guy. Not yet. So okay, RAM device. I can ship out. Okay. Okay. Let's say he added RAM into the constructor, so we should as well. RAM device RAM, so added RAM equal RAM. Okay, I think that's it. Wait, did I put? No, almost forgot. You need to make sure that they're both the same. The RAM device RAM. The reason that you put the asterisk sign, you really don't want like to make copies. You know, imagine you have a big array and you have to copy every time you wanna like do some read or write. That's not good. You want to actually access. You have to use the pointer to access the actual value, the actual thing. Okay. So now we are working on the this OBS. Now we are working on the read function. Let's see. What's this? Unaligned read. Okay, so basically, based on the diagram he shows here, you can see that if you each memory has each address has its own block, and it starts from the beginning and it's all the way up by 4 like this. So if you were to access this, if you were to access the first index or the first index here, it would be the same as accessing, like we also have access to this as well, basically the whole block here. And that's one block, that's one address. You can access everything in here. But if we were to let's say if we start at here, we end up here, that's alright, because here we are still within the same block, the same 32-bit number. But if we were to start something at like here at the I equal index 1, then we would end up here instead. You see, here we would end up here instead, and this would be called an unaligned read, because we're trying, like we are transpassing into another address. And actually in RISC-V they allow unalignment, but it's just really slow. So the reason that is yeah, the reason the reason that he uses this 1 1. So when you write 0b, it means that it has the compiler to treat this as a binary number. And since the 1 1 here refers to the last 2 bit. You see 0, 4, 8, C, something like this. What they all have in common is that their first two bits will always be 0. You get what I mean? So when you write 0b1, it's basically like 0 0 0 something like this, and then just the last 2 bit is like, I don't know, I probably added too much 0, but just like for example, it's actually equal this, but it doesn't put a 0. So we just need to compare the last 2 bit. If the last 2 bit is not 0, it means that this is an unaligned read. So we can say if address, we mask it with 0b, and it's not equal to 0, then we can so we are throwing an error, so okay, a print maybe. A print thing send error, and I think I need to include the library for this one. std-lib. Wait, am I missing some library? What's the name? Only fine. I don't know. st What's this thing like this? What library am I missing? Just search Google. Library I have to include to std. Okay, I'm gonna say unaligned read from address my bad, that's I confused it with something. I confused it with been working like on Laravel project. The string have to be like this, and I think this. So you want x like this? No. You want it to have it x and like this. I think the x basically like the 0 8 means that it should have at least 8, like at 8 numbers, because it's an address, and the x is to treat it as a hexadecimal. Okay, and I can pass in the address, I think, and after, if we have an error, we should just exit. Just to exit the program. Otherwise, we will because we will return what is oh wait, we have to check first. We have to check if it's ROM or what. So we can say address and equal to program. Instead, we can say we will return so the bits so how does this work? For example, I don't know. So our program ROM start is basically like this, right? For I think that's 7, yeah. And let's say our address is I don't know, something like this. Okay. So when we use the AND, when we use the bitwise operation, what we get is the bitwise is that if it's 1 and if it's 1 0, it will be 0. So we would get this, and by telling the 1 here, the start, we can say that is referring to the ROM. So we can return private, not RAM, ROM. Turn private ROM. I need to delete where. Return private ROM read, because this is inside the read function. Address and let's see.
And we're going to ignore, we're going to ignore the first number because that's a selector, then we're going to select everything else. 1, 2, 3, 4, 1, 2, 3, 4, yeah. And then the result of that, shift that down by 2 bits. I hope you see why I'm doing.
Okay. Yeah. So the reason that we do like this is it's just in case the address that was input, the address that was input might be bigger than 32-bit. The 32-bit, yeah, 32-bit. So we have to filter this out. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then we shift it by 2. If we don't shift it by 2, then we're trying to read an address bigger than what we have. If the address RAM start is the same as RAM start, then we know that trying to read from the RAM. So If you want to look at the diagram that you showed before, so this condition here is basically when the CPU want to communicate with the hardware. This is how the system interface know which device, which hardware to translate the data to, and then this is how it responds back to the CPU. What else did he do?
I'm just going to take that out. I'll write to ROM.
Okay. Let's see. This is oh, it's basically the same. This just is the same thing for write. But let's delete this because we cannot write to ROM. Just change this another line, right? And right. What's this? This only get the address. We need the value as well. But I notice he also has another condition at the top. He does not, but we need to make sure, like before we read it, I think we should make sure that our private ROM is not empty first. Like imagine it's empty and you try to read it, which is print garbage value. Same probably for this as well. Private RAM not null and okay. Okay. I think that looks pretty good to me. So what else did he do after that? From okay, sure, you can do that too as well. Just say value for say x 08 x, and then wait. Yeah, I think it's the same. Okay, let's see. Oh, so now this is like the main function. You see, he created ROM, he created bus, basically it's system interface. Okay. I mean, we can do that. We can. Let's see. I can create another file called. Actually, this source. Should probably have created a source. Oh, how do I create another big Nice. Let's focus. And what if it will give any error? It did. Okay.
Hello and welcome to this series where I'm going to be building
But what just happened?
bricks.
I don't know what happened. Let me fix the header first.
Hello and welcome to this series where
Why does it keep happening? What? I just call it RISC-V 32. I got C. Ah, that's weird. Maybe I don't need to include source. I think it works right now. Just put source. Just put it. No. The source. To make sure that it can find the right directory. Oh no, I have to write this for every single one of them. It's gonna take a while. You guys can skip this part. You should skip this part. Memory maps not including anything, so I'm not need to do that. And as we see, that's pretty much it. So it's basically we have to include everything, right? How many extensions do I even have? Sorry, I was drinking water. Okay. I think this is the equivalent of the main function he's doing here. Because he ran it, so let's include other necessary first. We obviously need source, let's see. Is it like this? Oh my god, what's wrong now? It's not loading. Okay. Sure. I don't really know what I'm doing, to be honest. Just include everything. ROM. And then that's all. So what is he trying to do? First he created a new RAM ROM and that. So guess we can create a ROM device. ROM equal ROM create. Yeah, see, we don't have the new keyword, so this is how we have to do it. This is what's happening now? ROM device. We need to pass it as a pointer. This are of the device, I guess. Reference it. I don't want to copy. I don't want to pass copy now. Just create RAM equal RAM. Yeah, they have the new keyword. So nice. It's really nice. Did I? Oh my god! What did? Again? Wait, what is this? Wait. Wait. Oh my god. Global RAM data equal RAM buffer. I did not create the RAM buffer. I have the RAM buffer, so wait. Why can't I access the RAM buffer? RAM size. I included the RAM, right? So you should be able to. Oh my god. The device is the RAM. Okay, return device. Okay. You have to write return the device. Because if you don't return the device, if you create it, how would you get the RAM, right? And MIO device, you can say create bus. System, it takes in ROM and RAM. Nice. What now? Don't tell me. Oh, I did not put it again. MMIO. Okay. Error should disappear now. It should. Return device. Return type, that's not much the function type. What do you mean? This. Put it RAM device, so how does it? It's a RAM. Maybe this. Ah, okay. See. So if the data type is a pointer, you have to return it with a reference sign. What next is just inputting data, I think. Okay, it's just inputting data into the putting data into the bus. The right bus, right. So let's see. Oh. What's he doing? Wait a minute. What the heck? What's this part? Okay. Here. So he's loading it into the ROM. Yeah. So now let's load it into the freaking ROM. So we have the RAM. Guess we have to create an array so that we can input like maybe init program. Because what do you put? Just copy his data, the beef, and what is it? Code cafe. Then I guess we can say bus dot write, which take in here, take an address and value. So oh wait, I need to load it into the ROM first. Right, not bad. ROM dot load. Okay, we can load I guess init program, and that's the two data. So okay, so now we have the, after we load, we just okay, after we load it, we just read it from the bus, right? So we can say read, yeah, because back to this thing, like it's one, like when we, so one address consumes this much, and this is the index. So this means that that beef, it needs to be like end with 0. Yeah. 1 2 3 4 5 6 7. This should output that beef. That beef is in this block, and if we want to, so this, then that means that this one, this, think of it as an array, right? First index, second index. So that beef is code cafe is basically in here. So if we want to read code cafe, we have to say bus read 1 2 3 4 5 6 4. Why? Because code cafe starts from 4. You see? You get what I mean? So this is how it works. And that's to test our error here when it's an unaligned read. So we can something like 5 is not allowed because it will overflow into the next address. So you can say bus, let's try to get let's try to do an unaligned read. So 1 2 3 4 5 6. Okay, and to make it easier for us, let's print some message to show that we did it successfully. So we can say, if this works, we can say printf. We can say ROM device, just ROM device created, and I guess new line. Okay, if this show, if the message show, then this means that this worked correctly. Printf, this means that ROM device created. Okay, then okay, and if this works, again, just copy paste this bus device created. Okay, I guess if we successfully load, I guess we can say successfully load the data into the bus. We can say ROM loaded, I guess. ROM loaded. Yeah. So now with this, I guess let's try this image first. Well, okay, let's open the terminal and to compile this, if I remember correctly, like GCC I think I have to put all the source, so like compile the index. No, it's not index, because compile everything here. Just compile source dot to i.c source system interface system. Why do I keep writing index? C and then source system interface so system interface RAM device.c source system interface ROM device. Oh, actually, I put it as put RAM there. And then to should work. Yeah, I think that's 1 2 3 4 1 2 3 test 4 C file. I think that's all. Yeah, so we do like this, and then let's call it simulator exe. Define it in the directory that I'm in. Then just run it after you are done. Just run the simulator.exe. What's that? I've got this. Okay, what's happening? MMIO device, RAM device. I guess I forgot to include. Wait, I forgot to include RAM. Let's try running it again. RAM. My God. Okay. RAM. What's this? Why there's so many errors? Okay. Let's try creating it, fixing it one by one. Printf. I think I forgot. To print, I think it was standard IO. I think it should be input output. Okay, system right. System right declared here. Static void. Address value. What's this? Let's go with this one. Error. And here system right. Address. Error assigned to aka system right device.right equal system right. Oh my god, what's happening? Oh no, I hate this. Device right, system right. What's wrong here? Okay. Let me pause a bit. Oh, okay. So what I found is that it was because in this here when I put it in here, the compiler, it does not know what even ROM or RAM device is yet. So that's why we have to use tab there first so that it understands and that it can actually load this. And let's see, program ROM start. I forgot to and I updated the main function bit so that you can see the actual display when we run it. This is just like this. Okay, memory map. Okay, it should work. Why is it like this? Program. Why does it not understand this? I'm pretty sure I put it here. Program start. Okay, so now let's try running the code again. Why is it like this? Oops. You're supposed to print everything, not like that. RISC-V. Okay, let me fix this one again. Okay, so I decided to update the main file a bit. So if this code works, it will go here, it will print that it's created. If the ROM work, it show that ROM is created, RAM created, ROM ROM loaded, bus created, and then we have this is just to print the data that we put into the ROM, and it will also print all the elements that we have. So let's just run the code. So this, and here you can see this hardware was successfully created, and this is the data that we loaded into the ROM, and then we check the ROM assigned to, and we here, since there are only 2 items, it only shows those 2. The rest is basically 0, so we don't have to input that. and when we try to read from the address I told you, we show that unalign address and it exits out of the program. So this is basically the progress that I made so far, and the next we will be uploading more video in the future. Thank you for watching. Yes. Yeah, really thank you for watching.